So today we have an interesting geometrical problem. We have a circle, then we inscribe 4 quarter circles inside it in this specific pattern as you can see in this diagram. Now there are two things to be noted. The first thing is that this particular point where all these quarter circle meet is not the center of this circle, and this particular line and this particular line are complete straight lines. Now the question is, what fraction is shaded, that is ratio of area of this quarter circle to the area of the circle. So let us see the solution. How can we find what fraction is shaded? So first of all, we will start the solution by marking the radius of this quarter circles and the radius of this circle. Okay, so we have taken the first quarter circle as blue one and having radius A, the second one is orange one having radius B, the third one is the purple one having the radius C, and the fourth one is the yellow one having the radius D, and the radius of this complete circle we have taken as R. Okay, so now we will utilize the fact that these are quarter circles and they are arranged in this specific pattern. So as per the given data, we know that these are quarter circle, and in quarter circle their corner angle is 90 degree. So for this fourth one this is 90, for the third one this is 90, for the second one that angle is 90, and for the first one this is 90. Okay, now as these angles are 90 degree and this line were straight lines, so we can easily say by symmetry that over here this angle is 90 degree. This means that this line and this line are intersecting each other at 90 degree. This fact we will utilize in a moment. Now concentrate in this first quarter circle. I will draw a line segment from this particular point to this particular point. Okay, so now we have formed an isosceles right angle triangle over here because 90 degree is already there, and this side is already equal because they are the radius of the quarter circle. So here we have an isosceles right angle triangle, so ultimately this angle and this angle are going to be equal and they are going to have a value 45 degree. So these two angles are equal and they have a value 45 degree, remember that. Now the similar thing we will do in this third quarter circle. Again the same line segment I will draw. Again we have formed an isosceles right angle triangle. This side and this side is equal because this is the radius of this quarter circle. Again this angle and this angle are going to be equal and they are going to have a value that is 45 degree. So here we have drawn two line segment in the first quadrant circle and in the third quadrant circle. Now the question is that, is this line a straight line? Yes, this is a straight line and we can easily prove that because as this angle is 90 degree, so by linear pair this would be 90 degree, this part is already 45 degree, so this would be 45 degree. Now here we can say that 45 degree plus 90 degree plus 45 degree is 180 degree. This completes the proof that yes, this line is going to be a straight line as the sum is 180 degree. Now the similar thing can be done with this second quadrant circle and the fourth quadrant circle. Again they are hypotenuse joined, so I will directly join the hypotenuse from this particular corner to that particular corner. So here we have joined the line segment and this line would also be a straight line as we have shown the proof for this one. The same thing you can do for that one also. Now what can you say about the length of this line segment? As we have taken the radius of the first one as A, the second one was equals to B, for the third one it was C, and for the fourth one is equals to D. And as this were isosceles right angle triangles, so these two sides are A and A, these two sides are B and B, similarly over here C and C, and similarly over here D and D. Now this is a right angle triangle, two of its side is A and A. So by Pythagoras theorem we will get that the hypotenuse is square root of 2 times A. Over here we will get that the hypotenuse is square root of 2 times B. Here the hypotenuse would be equals to square root of 2 times C, and over here the hypotenuse is going to be equals to square root of 2 times D. So you might be thinking why we are calculating the length of this line segment. This is because this line segment are the chords of this circle. So first of all, to relate a thing between the circle and the chord, what we need is the length of the chord. And the second thing is that at what particular angle the chords are intersecting. So that is also very easy to be found over here. As this angle over here is a 90 degree angle, so this angle would also be 90 degree. This is already 45, so this would be 45 again. This is an isosceles right angle triangle, so this angle would be 45 degree. So 45 plus 45 is 90 degrees. So here we have got that yes, these two chords are ultimately intersecting at 45 plus 45, that is 90 degree. And also we have the length of this particular chords. So what I am thinking is to redraw this diagram, but this time only with the circle and these two chords. So here we have drawn another diagram only containing the circle and these two chords. Now the length of these two chords were like this way. This much line segment was having a length square root of 2 times A. This much for having square root of 2 times B. This was having square root of 2 times C, and this was having square root of 2 times D. Now as we are going to do many things over here and these lengths are not very good, so we will take them as another variable, like square root of 2 times A we will take as X, square root of 2 times B we will take as Y, square root of 2 times C we will take as Z, and square root of 2 times D we will take as W. So now we will continue the solution with these particular variables. So as per our new variable table, this length is x, this length is y, this length is z, and this length is w. And these two chords were intersecting at 90 degree. Okay, now the fact that we have not utilized till now is that all the things were inside a circle. And if we are discussing a circle, the first thing that we should do is mark the center of the circle. So we will take some other point other than this because it was given in the question. So I am taking the center over here. Okay. Now we are going to utilize the theorem, that is this one. If we draw a perpendicular from the center of the circle to the chord, it will bisect the chord, and I have shown the proof also. So here also we will draw two perpendicular lines to these two chords. So here we draw the first one and here we go with the second one. And as these are perpendicular lines, 90 degree marking over there and over here. Now as these two chords were intersecting at 90 degree over there, we can see, so by vertically opposite this is 90, and by angle sum property in this particular quadrilateral, this angle is going to be 90 degree. So as all the four angles in this quadrilateral is 90 degree, so it forms a rectangle, and in rectangle opposite side is equal. Okay, so remember this thing, and we are going to utilize it in a bit moment. Now as we have drawn the perpendicular, so it is going to bisect the chord. So the length of this complete chord is w plus y, and because of this perpendicular, this much length is going to be equals to complete length, that is w plus y upon 2, because it has been bisected at this particular point. Now there is something else also. From here to here the length is w, from here to here the length is w plus y upon 2. So this remaining length is going to be equals to longer minus the shorter. So w minus w plus y upon 2 would give me a length, that is w minus y upon 2. So this is the length of this particular line segment. So as I told you before that this is a rectangle and opposite side is equal. So this much length is w minus y upon 2. So this length is also w minus y upon 2. Okay. Now we also have one more perpendicular line to this particular chord. The length of this chord is x plus z, and because of this perpendicular it will be bisected as half. So from here to here the distance is going to be the complete length upon 2, that is x plus z upon 2. So this much length is x plus z upon 2. This much length is w minus y upon 2, the 90 degree over here, because we have drawn the perpendicular by ourselves. And what I will do is draw a line segment from this particular point to this particular point. Now what can you say about the length of this line segment? Yes, of course, it is the radius of this particular circle, because from the center to the boundary, and we have taken the radius of the complete circle as equals to r in the beginning. So length of this particular hypotenuse is r. This length is w minus y upon 2. This length is x plus z upon 2. We have a 90 degree over there. So we are going to simply apply the mightiest theorem, that is the Pythagoras theorem. So the Pythagoras theorem in that particular triangle, so w minus y upon 2 the whole square plus x plus z upon 2 the whole square would be equals to r square. Remember that x, y, z and w is having a value in terms of a, b, c and d. Now opening the brackets over here, so w square plus y square minus 2 times w times y plus x square plus z square plus 2 times z times x. I have taken the common LCM as 4 directly, and this thing is going to be equals to r square. So we were having things like this way, a circle and two chords that are intersecting, and length of this specific line segments were x, y, z and w. So now here we can simply apply the intersecting chord theorem. The proof is on the screen. As per the theorem that we just saw, x into z would be equals to y into w. So x into z is going to be equals to y into w. Now look, in this particular equation we have negative 2 times wy and positive 2 times zx, and as these two values are equal, they are going to cancel out each other. So the remaining equation is x square plus y square plus z square plus w square is going to be equals to 4 times r square. Now as we have taken the length of square root of 2 times a as x, this was square root of 2 times b, this was square root of 2 times c, and this was square root of 2 times d. Let us put them all back over here. So here we can see that these values are square. So square root of 2 times a the whole square will turn out to be 2a square. Similarly, y square will turn out to be 2b square. Z square will be 2 times c square, and w square will be 2 times d square, and this thing is going to be 4 times r square. We can factor out the 2. So a square plus b square plus c square plus d square is going to be equals to 2 times r square. Now this is the most important equation in the solution, because this thing would ultimately give us the answer to the ratio that we are trying to find. Let me show you. So the required ratio that we have to calculate is the combined area of this quarter circle to the area of the circle. So I'm writing it over here. The required ratio is going to be equals to, now area of a quarter circle is pi the radius square upon 4, and as the radius of this quarter circle are a, b, c and d. So area of the first quarter circle is pi a square upon 4. The second would be pi b square upon 4. The third one would be pi c square upon 4, and the fourth one would be pi d square upon 4. So here we have combined the area of this quarter circle. Now upon area of this circle, so radius of the circle we have taken as r, so area would be pi r square. Now we can say that pi, 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 and all this pi got factored out. And from the numerator we can take 1 upon 4 common. So inside the bracket it is going to remain a square plus b square plus c square plus d square. And in the denominator we have r square. Now remember this particular equation, that a square plus b square plus c square plus d square is 2r square. So over here a square plus b square plus c square plus d square can be replaced with 2r square. So this thing would turn out to be 1 upon 4. 2r square upon r square and r square got cancelled out. From the table of 2 it goes 2. So the required ratio is going to be equals to 1 upon 2. That is, the combined area of this quarter circle is going to be exactly half the area of this circle. So this was my way to solve this particular question. If you have any other method other than this, you can do comment below, and if it's hard to comment, you can email me, or else you can send it to me on my Instagram or Discord. The links are in the description.